Hey everybody, thanks for pausing for a moment of science. I want to do a really cool experiment with you today, and we are going to make our very own hot air balloon. I like to make hot air balloons because it's a great way to show convection and also to put an image in your mind on how when air is heated, it expands and gets light enough that it will actually begin to float. So let's do that together today. The first thing you will need is you will need 2 tea bags. Now, the only type of tea bag that works in this experiment is Luzianne brand. Luzianne tea bags are made different than like Lipton or Food Lion, Walmart brand, whatever. It has to be Luzianne brand tea bags, okay? You need scissors, matches or a fire starter, and a trash can nearby. So the first thing you will do is you'll take your tea bag and unhook the tag, and then you are going to cut the top off, the folded part. If you can see, the top of the tea bag is folded right here, and there's a staple, and we don't want that. And we want to cut it as straight as we can. All right, ish. So throw that away, and then we don't need the tea that's inside, so we're just going to discard that. So I'm just gonna have a trash can nearby, and this is what you have left. And the reason why Luzianne tea bags work and the other brands don't is because Luzianne uses one giant tea bag and then they fold it. Other companies use 2 small tea bags and they either glue them together or staple them together here, and so it won't work. You need one really long one. Now, to give us some time to watch and process what's happening, I like to make a double layer, so that's why I use 2 tea bags. So the same thing as you're going to, trim the top off, just like you did with the other one, as straight as possible. Dump out the tea, and then make a double layer. So slip this tea bag inside the other, and then take your fingers on the inside and just kind of open it up. There we go. So just like that. When you are finished, it should look like a toilet paper roll. See, right there? Okay? Now, I have to tell you this part. Typically on a hot air balloon, the heat source is at the bottom. The air is heated, which makes it expand and then rise into the balloon. And because the inside of the balloon air is thinner and lighter than the outside air of the balloon, it causes it to rise. The problem with that is if I light this on fire, fire does not burn evenly. If you've ever looked at a flame or a campfire, it's all different colors. And the reason why it's all different colors is because it's all different temperatures. The bluer it is, the hotter it is, the more yellow it is, the less hot it is. And so okay, sorry, had a little interruption there, but that's okay. What I was talking about is I was talking about how when you have a flame, it is different colors because it is different temperatures. And that poses a problem because if I light this on the bottom, the hotter parts of the flame are going to burn more quickly and the less hot parts are going to burn more slowly, which will cause it to burn unevenly, and it can't stand up nice and tall. If one side is burnt more than the other, it will tip over. When it tips over, the hot air will escape from the outside and go up into the atmosphere, and you're not going to get anything started that way. So we have to kind of cheat the system a little bit. And how we do that is I'm actually going to light it from the top. And I know that that sounds counterintuitive because the fire will be here, which means the heat will be here. And we need it here. So it will burn down, and when it gets small enough, you will see that the bottom begins to glow. And when you have that glow, you are getting more light, and if you are getting more light, you are getting more heat. So it will begin to heat the inside air, but unfortunately it doesn't do that until it's burnt down and it's very, very small, and then it has the ability to heat the inside. When the air inside the hot air balloon is hot enough, it will become light enough and it will begin to rise into the atmosphere. Now, we don't have to get out of the way for when it comes down, because remember, what goes up must come down. But I know for positive that even if it lands on my head, I will not get burnt. It is impossible for me to light this on fire, send it up into the atmosphere, and when it comes back down, land on me and me get burnt. Because hot cannot go down. All right? So what happens is as it goes up, it begins to lose its energy. Remember, fire loses energy. It gives off energy. It doesn't last forever. And eventually, it will have lost its energy, and that will cause it to cool and contract and then fall back down. So if it falls on me, that's because it's cool. Like, not cool, but like cool. So I can't get burnt if it's coming back down, because I know for certain if it's falling, that means it's cool. All right, so let's go ahead and light this and watch what happens. Okay, so I'm gonna light the top. I fell into a burning ring of fire. And I want you to keep your eyes right here. Ooh, there it is. There's that glow. It's gonna get, whoop, 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 whoop. And then here it comes back down. Let's see if you can see it. Oh, boom, there it is. All right, so I'm going to light one more and send it up and actually do my camera with it so that you can watch it rise and watch it fall, okay? All right, here we go. I'm gonna light the top. And remember, we're looking for that glow right here on the bottom. There it is. And ah! Okay, I'm gonna light the top. Let that burn down a little bit. And you'll see when it starts to heat on the inside, you'll see it glow. Oh, see the glow? Get ready for liftoff. And then as soon as the last spark goes out, it begins to lose its energy, cools off, and falls right back down.